We are asked to draw the 8 constitutional isomers for C5H11Cl, to give their IUPAC name, to classify each alkyl halide as primary, secondary, or tertiary, to identify any stereocenters, and to draw the stereoisomers and then label them R or S. This is a pretty all-inclusive problem here. We're tying in a lot of stuff. So let's jump right in and start with drawing our isomers. So we know everything is going to have 5, and the ratio of carbons to hydrogens means that we are not going to have any rings, nor are we going to have any double bonds. Everything is going to be single chain, normal alkane. So I'm going to start in here and draw the simplest version first, just linear pentane, and then I'm going to put a chlorine off the end. And we can just double check here on this first one to make sure we've got the right number of everything. I have 5 carbons, 1, 2, 3, 4, 5. And then I'm going to have 3 hydrogens here, 2 hydrogens here, 2 here, 2 here, and 2 here. 2, 4, 6, 8. 8 plus 3 is 11. We have 11 hydrogens and our chlorine. We're good on our numbers, so satisfied that we're going to be doing this right, we can continue on and not need to count like that. So for these first ones, I'm just going to move the chlorine around like that. And now that's as many unique shapes as I can make by just moving the chlorine. If I were to put it on this carbon here, it would just be this structure, but flipped. So now we have to move the carbon. I'm going to get these four carbons down and then stick one off on the side. Now we need to put the chlorine on. I'm just going to put it on that carbon there. We're going to have the same base here. I'll move the chlorine down 1 carbon. We see if we put the chlorine on this carbon, that would be equivalent to structure 4 here. So we have to keep moving it down the line. That's a unique structure. It's a unique structure. And then finally, for our 8, there's only one way we can orient these left. Just like that. So we have 3, 6, 9, 10. Oh, excuse me, not 10. That carbon has 4 bonds. 10, 11. There we go. That's all of our hydrogens accounted for. So here are 8 structures. Let's get in with our IUPAC names. So for this first one here, we have pentane, just in a nice line. And we remember that we always number to give our groups the lowest locator numbers. So I'm going to number from the chlorine, and this is going to be 1 chloropentane. Ane, because there's no double bonds, no rings, so we have no cyclo. 1 chloropentane. Here, do the same thing for numbering to make sure that it has the lowest locator number. We have then 2 chloropentane. 3, we're going to have 1, 2, 3. 3 chloropentane. Now 4 is where it starts to change a little bit. We want to make sure that we're keeping track of our main chain. Our main chain is right here. Now we have 4 carbons in our main chain. We still have 5 total, that one hanging out there. But I numbered it this way because it gives our groups lowest locator numbers. 1 chloro, 2 methyl butane. Bute now because we have 4 carbons in our main chain. Chloro comes first because C is higher up in the alphabet than M. On to 5. Again, keeping track of our main chain here. We have 1, 2, 3, 4. And of course, this would be the same as if I said that carbon was 1 instead. Those groups are equivalent. I'm just going to number it like this. So, just like that last one, chlorine comes first, 2 chloro. I'm missing an H. I looked wrong. 2 chloro, 2, oh, I did it again. 2 methyl butane. Now, we're going to give chlorine the lower locator number for numbering here. So it's a higher priority group than the methane. So we have again 2 chloro, 3 methyl butane. Same convention here. 1 chloro, 3 methyl butane. Now again, we got to keep track of our main chain. Can number it any which way. All 3 of these carbons are equivalent, but I'm going to call it 1, 2, 3. Oh, I went backwards. Again, lowest locator numbers, 1, 2, 3. There we go. So now we have 1 chloro, 2 dimethyl, because we have 2 methyl groups on 2, propane. Prop because we have 3 carbons in that chain. That's the names for all of our isomers here and the structures of them. So let's go through and let's identify our alkyl halides. On 1, we see this carbon 1 only is attached to carbon 2, where chlorine is, so this is going to be a primary. Here it's attached to the carbon the chlorine is attached to 2 other carbons, so we have secondary. Here as well, we have just the 2 carbons attached here, so secondary. For 4, it's attached to a carbon that's attached to a carbon, so primary. 5, we have something different. 1, 2, 3 groups attached to that carbon, so we have a tertiary here. 2 carbons attached, secondary. Just on the 1, primary. And again, here, that's just primary. Even though there is this center right there, we're only looking at this carbon. Okay, now stereocenters. Let's scan through these to determine which have stereocenters. Structure 1 has no carbons with 4 unique groups. Structure 2, has a center here with 4 unique groups: a methyl, a propane chain, a hydrogen, and the chlorine. we have a stereocenter. It's on carbon 2. Both of these chains are symmetric, they're equivalent, so this does not have 4 unique groups. For 4, we have 2 hydrogens here. These 2 methyls are equivalent, so they're not unique. For 5, on 6, we have a methyl, a unique propane chain there, a hydrogen, and the chlorine. We have another stereocenter, and it's also on carbon 2. For 7, we have 2 methyls here, and for 8, again, 2 methyls. So just 2 and 6 end up being our stereogenic structures. Now we need to draw our stereoisomers. So I am going to scoot this structure up here. I can keep this. Oh boy. I'll just rewrite it. I'm going to keep the 1 just for having it. Sentimentality, maybe. And now we get to draw. So I'm going to say structure 1 is going to have chlorine coming forward and the hydrogen going back. Now the other version of this would have the hydrogen coming forward and our chlorine going back. So let's number our groups. I'm going to start with this top one. Chlorine is our biggest group here. Next, remember, we're just looking at the groups that are directly attached to this carbon. So carbon 3 and carbon 1 would be equivalent, but then we look to what's connected to them. Carbon 3 is attached to another carbon and 2 hydrogens. Carbon 1 is attached to 3 hydrogens. So carbon 3 is our second priority. It's higher than carbon 1. Carbon 1 then would be our group 3, and of course our hydrogen is always our lowest priority group, it's number 4. So drawing our rotation here, we see it's turning left, so that is an S configuration. Down here, we'll do the same thing. Our groups don't change, even though the stereochemistry changed here. We're going to draw our twist again here, but because our lowest priority group is shown coming forward, we can't have that, and so we know to flip the sign here. So this would be an R configuration. Okay, so that is our labeled structures. Let's pop down to 6. Just gonna scoot that over there. Scoot that up. And again, just for ease of drawing, I'm going to make this chlorine go forward and the hydrogen go back. And now for the second stereoisomer, we just do nearly the same thing like that. Okay, same deal as before. Chlorine's our number 1 priority because it's the highest priority group here. Comparing carbon 1 and 3. Carbon 3 is attached to 2 other carbons. Carbon 1 only has hydrogens. So carbon 3 becomes our second priority. Carbon 1 is our third. And as always, hydrogen is 4. Draw our rotation. We see this is an R configuration. Down here, again, we have the same priorities as before. We see it's still R, but because the chlorine is going back, we're going to flip it, so that makes it S. And there you have it. Very involved problem to draw all 8 constitutional isomers, give the IUPAC names, classify all alkyl halides, primary, secondary, tertiary. We identified the stereogenic centers. We drew the stereoisomers, and we labeled each of them R and S.